Welcome to the Sleep and Learn channel. We invite you to listen to interesting scientific facts that will help you fall asleep gently and, at the same time, learn something new. Relax, close your eyes, and let a calm voice guide you into the world of knowledge and sweet sleep. The coral kingdoms and coastal worlds. Along the edges of continents and islands, where land meets sea, some of the ocean's most intricate ecosystems quietly flourish. Coastal regions form transitional spaces, neither fully terrestrial nor entirely marine. And within these shifting boundaries, life adapts with remarkable balance. Coral reefs are among the most structured and biodiverse of all marine environments. Though they appear to be colorful underwater gardens, reefs are built by small colonial animals known as coral polyps. Each polyp secretes a limestone skeleton, and over thousands of years, these skeletons accumulate into vast reef systems. The Great Barrier Reef, for example, stretches for more than 2,300 kilometers along Australia's northeastern coast, forming one of the largest living structures on Earth. Reefs thrive in warm, shallow waters where sunlight can penetrate easily. Within their complex formations live countless species of fish, mollusks, crustaceans, and algae. The coral structures provide shelter, feeding grounds, and breeding sites, creating a network of interdependent relationships. The diversity found in reef systems rivals that of tropical rainforests on land. Beyond coral reefs lie mangrove forests, coastal wetlands where salt-tolerant trees grow in tidal zones. Mangroves anchor themselves with intricate root systems that rise above the waterline, forming natural barriers against erosion and storm surges. These roots create sheltered nurseries for juvenile fish and crustaceans, offering protection during early stages of life. Seagrass meadows also play a quiet but essential role in coastal ecosystems. Though often overlooked, these underwater flowering plants stabilize sediments, filter water, and provide grazing grounds for sea turtles and dugongs. Seagrass beds absorb significant amounts of carbon dioxide, contributing to climate regulation in subtle yet important ways. Rocky shorelines and tidal pools reveal another dimension of coastal life. As tides recede, shallow pools remain trapped among rocks, temporarily isolating small ecosystems. Within these pools, starfish, anemones, small fish, and crabs endure changing temperatures and salinity levels. Adaptation to these fluctuations has led to resilient and specialized forms of life. Sandy beaches, though seemingly simple landscapes, are dynamic environments shaped constantly by waves and currents. Beneath the surface of the sand live burrowing organisms such as clams and small crustaceans. Shorebirds patrol the water's edge, feeding in rhythm with the tides. Estuaries, where rivers meet the sea, represent zones of gentle mixing between freshwater and saltwater. Nutrients carried by rivers accumulate in these regions, supporting abundant plant and animal life. Many fish species depend on estuaries as breeding grounds before venturing into the open ocean. Coastal ecosystems also serve as protective buffers for human communities. Coral reefs reduce wave energy before it reaches shore. Mangroves slow storm surges. Seagrass beds stabilize sediments. In this way, nature's coastal systems quietly support both marine life and human settlements. Yet these environments are sensitive to change. Rising sea temperatures, pollution, and habitat disruption can alter delicate balances. Coral bleaching, for example, occurs when stressed corals expel the symbiotic algae that give them color and energy. Even so, some reefs show resilience, slowly recovering when conditions stabilize. The coral kingdoms and coastal worlds remind us that the ocean's richness often lies closest to shore. In shallow waters illuminated by sunlight, complexity unfolds gently. Roots intertwine, tides recede and return, and countless species move in harmony within ever-shifting boundaries. The gentle power of waves and currents. The surface of the ocean is rarely still. Even on the calmest days, subtle ripples move across the water. carrying energy that may have traveled thousands of kilometers. Waves are not masses of water journeying across the sea, but rather movements of energy passing through it. Each wave rises, curls, and falls, while the water itself mostly remains in place, moving in gentle, circular patterns beneath the surface. Most ocean waves are created by wind. As air moves across the water, friction transfers energy into the surface, forming small ripples. When winds are strong and sustained, these ripples grow into larger waves capable of crossing entire ocean basins. A wave that begins during a distant storm can arrive quietly at a faraway shoreline days later, transformed into a slow, rhythmic swell. Ocean swells are among the most soothing movements in nature. Unlike short, choppy wind waves, swells are long and evenly spaced. They rise and fall with steady intervals, creating the rolling motion often associated with calm seas. Sailors and coastal observers have long relied on swells to sense distant weather patterns beyond the horizon. Beneath the visible surface, powerful currents flow continuously. Ocean currents are often described as underwater rivers, moving vast quantities of water in organized pathways. Some currents are driven by wind, especially those near the surface. Others are shaped by differences in temperature and salinity, a process known as thermohaline circulation. Thermohaline circulation operates on a global scale. In colder regions near the poles, seawater becomes denser as it cools and as sea ice forms, leaving salt behind. This dense water sinks and begins a slow journey along the ocean floor. Over time, it travels across entire basins before gradually rising in other regions. This immense system is sometimes called the global conveyor belt. The movement of currents helps regulate Earth's climate. Warm currents carry heat from tropical regions toward higher latitudes, while cold currents flow toward the equator. Without these steady exchanges, global temperature differences would be far more extreme. The ocean quietly redistributes warmth, maintaining balance across continents. One of the most well-known currents is the Gulf Stream, which transports warm water from the Gulf of Mexico across the Atlantic Ocean toward Europe. Its influence contributes to milder winters in parts of Western Europe compared to other regions at similar latitudes. In addition to large-scale currents, the ocean also experiences tides. Tides are caused primarily by the gravitational pull of the moon, with assistance from the sun. As Earth rotates, coastlines pass through bulges of ocean water, creating the gentle rise and fall observed daily. These predictable rhythms have guided human navigation and coastal life for centuries. Sometimes, under specific conditions, the ocean demonstrates sudden power. Tsunamis, triggered by underwater earthquakes or volcanic activity, can travel across entire oceans at high speeds. Yet in the open sea, a tsunami may pass almost unnoticed, its energy spread across great depth. It is only near shore that this energy rises dramatically. Despite these immense forces, most of the ocean's motion is patient and continuous rather than violent. Waves breathe along the shoreline. Currents circulate slowly beneath. Tides rise and fall with dependable rhythm. Together, they form a system of motion that has endured for billions of years, steady, balanced, and quietly powerful. The ocean is never truly still, yet its movements often feel deeply calming. In its flowing patterns, one can sense both strength and serenity, a reminder that power does not always need to be loud. The hidden life beneath the surface. Beneath the ocean's reflective surface lies one of the most diverse ecosystems on Earth. Marine life exists in nearly every layer of the sea, from sunlit coastal waters to the deepest trenches where no light has ever reached. Although the ocean may appear calm and empty from above, below it thrives with quiet movement and extraordinary forms of life. The uppermost layer of the ocean, known as the epipelagic or sunlit zone, supports the greatest concentration of marine organisms. Here, sunlight enables photosynthesis, allowing microscopic plants called phytoplankton to flourish. These tiny drifting organisms form the base of the oceanic food web. Though nearly invisible to the naked eye, phytoplankton produce a significant portion of the oxygen in Earth's atmosphere. Floating among them are zooplankton, small animals and larvae that drift with currents. Many marine species begin life as plankton before developing into fish, crustaceans, or other forms. This drifting stage connects distant regions of the ocean, as currents carry young life across vast distances. Coral reefs, often called the rainforests of the sea, represent some of the most vibrant ecosystems in shallow waters. Built slowly by colonies of tiny coral polyps, reefs create intricate limestone structures that provide shelter for thousands of species. Fish of many colors move among coral branches, while sea turtles and reef sharks patrol calmly through these underwater cities. As depth increases and sunlight fades, life adapts in remarkable ways. In the mesopelagic, or twilight zone, many organisms possess large eyes to capture the faint remaining light. Others generate their own illumination through bioluminescence, a natural chemical reaction that produces soft blue or green light. In the darkness, brief flashes appear like distant stars. Deeper still, in the bathypelagic and abyssal zones, sunlight disappears completely. Temperatures drop, and pressure increases to extraordinary levels. Yet even here, life persists. Strange and delicate creatures drift slowly through the darkness, conserving energy in an environment where food is scarce. Some species grow slowly and may live for many decades. On the ocean floor, hydrothermal vents release mineral-rich water heated by Earth's internal energy. Around these vents, entire ecosystems thrive without sunlight. Instead of relying on photosynthesis, microorganisms use chemical energy in a process called chemosynthesis. Tube worms, deep-sea crabs, and other specialized species cluster around these warm oases in the cold abyss. The ocean is also home to the largest animal ever known to exist, the blue whale. Though immense in size, it feeds primarily on small krill, filtering thousands of liters of water with each mouthful. Its slow movements and deep, resonant calls can travel great distances through the sea. Migration connects many marine species across continents. Some whales travel thousands of kilometers each year between feeding and breeding grounds. Sea turtles return to the same beaches where they once hatched. Even tiny fish follow seasonal patterns shaped by temperature and currents. Despite this diversity, much of marine life remains undiscovered. Scientists estimate that many species have yet to be identified, especially in the deep sea. Each expedition into unexplored waters often reveals new organisms, expanding our understanding of life's adaptability. The hidden world beneath the surface reminds us that silence does not mean emptiness. In the ocean's layered depths, life moves patiently and continuously, glowing softly, drifting with currents, and thriving in places once thought impossible. The vast blue planet. The ocean is the largest and most continuous habitat on Earth. Covering more than 70% of the planet's surface, it forms a vast, interconnected body of water that shapes climate, geography, and life itself. From space, Earth appears as a deep blue sphere, and it is this immense oceanic blanket that gives our planet its calming color. Scientists divide the global ocean into 5 major regions: the Pacific, Atlantic, Indian, Southern, and Arctic oceans. Yet, in reality, all these divisions are part of a single, continuous world ocean. Water circulates slowly between them through powerful systems of currents, creating what oceanographers sometimes call a planetary heartbeat. The Pacific Ocean is the largest and deepest of all. It alone covers more surface area than all the continents combined. Within its depths lies the Mariana Trench, the deepest known point in the ocean, descending nearly 11 kilometers below sea level. If Mount Everest were placed inside it, the peak would still be submerged beneath the water. Despite its immense size, much of the ocean remains unexplored. Marine researchers estimate that more than 80% of the ocean floor has not yet been fully mapped or studied in detail. In many ways, the deep sea is less familiar to humanity than the surface of the moon. The ocean is not only vast horizontally, but also vertically layered. Sunlight reaches only the uppermost zone, known as the epipelagic or sunlit zone. Below it lies the twilight zone, where light fades into darkness. Deeper still is the midnight zone, a realm of complete blackness where sunlight never penetrates. Yet, even in these silent depths, life continues. Ocean water itself is a complex and balanced solution of minerals and salts. The average salinity of the ocean is about 3.5%, meaning that for every liter of seawater, roughly 35 grams consist of dissolved salts. This salinity helps regulate buoyancy, allowing marine organisms to float, drift, or swim with minimal energy. The ocean also acts as Earth's great climate regulator. It absorbs heat from the sun during warmer months and slowly releases it over time. This gradual exchange moderates global temperatures, preventing extreme fluctuations between day and night or between seasons. Coastal regions, influenced by nearby waters, often experience milder climates than inland areas. Even the soundscape of the ocean contributes to its tranquil character. Waves breaking gently along shorelines create rhythmic patterns that many people find deeply soothing. These steady sounds are the result of wind transferring energy into surface waters, forming waves that travel across great distances before softly reaching land. The ocean's vastness invites stillness. Its horizon appears endless, and its steady movements suggest continuity and balance. For thousands of years, humans have been drawn to its shores, not only for food and travel, but for reflection and calm. And beneath its shimmering surface, an entire world continues quietly, layered, mysterious, and patiently unfolding. The deep ocean and the silent abyss. Far below the reach of sunlight lies the largest habitat on Earth, the deep ocean. This immense region begins roughly 200 meters beneath the surface, where light fades into darkness. Beyond this boundary stretches a vast world of pressure, cold, and quiet persistence. As depth increases, sunlight diminishes rapidly. By 1,000 meters, the ocean enters the bathypelagic zone, often called the midnight zone. Here, darkness is complete. No sunrise or sunset marks the passage of time. Instead, the deep sea exists in a steady state of shadow, illuminated only by rare natural glows. Pressure in the deep ocean rises dramatically. For every 10 meters of descent, pressure increases by approximately 1 atmosphere. In the deepest trenches, pressure can exceed 1,000 times that at sea level. Yet life has adapted to these conditions with remarkable resilience. Many deep-sea organisms possess flexible bodies and specialized cellular structures that allow them to withstand such forces. Temperatures in the abyssal plains typically hover just above freezing. Despite the cold and darkness, these plains cover more than half of Earth's surface. They are among the most expansive and least disturbed environments on the planet. Fine sediments drift downward from above, forming what scientists sometimes call marine snow, a gentle fall of organic particles that sustains life far below. Bioluminescence is one of the defining features of the deep ocean. Many organisms produce their own light through chemical reactions within specialized organs. This soft glow may serve to attract prey, communicate, or camouflage. In the darkness, these flashes resemble distant constellations scattered through the sea. Some deep-sea fish have evolved elongated bodies, large jaws, and sensitive lateral lines that detect subtle vibrations. Others move slowly, conserving energy in a realm where food is scarce. Giant squid and other elusive species inhabit these depths, rarely observed, but long present in oceanic ecosystems. At the very bottom of the ocean lie deep trenches formed by tectonic activity. The Mariana Trench, located in the Western Pacific, represents the deepest known point in the ocean. Even here, microorganisms and small crustaceans have been discovered, demonstrating life's extraordinary adaptability. Hydrothermal vents and cold seeps punctuate certain regions of the deep sea. These geological features release mineral-rich fluids from beneath the sea floor. Around them, ecosystems flourish independently of sunlight. Microbes convert chemical energy into nourishment, supporting tube worms, shrimp, and other specialized creatures. Sound travels efficiently through seawater, and in the deep ocean, low-frequency calls from whales can move across vast distances. In the absence of light, acoustic signals become essential. The deep sea is not entirely silent, but its sounds are slow, distant, and resonant. Though technology has advanced exploration, much of the abyss remains unmapped. Submersibles and remotely operated vehicles reveal glimpses of landscapes shaped by volcanic ridges, sediment plains, and towering underwater mountains known as seamounts. Each expedition expands understanding of a realm still largely unknown. The deep ocean is a place of stillness rather than emptiness. It is a world shaped by pressure and patience, where life moves slowly and light appears only in gentle pulses. In its quiet vastness, the abyss reminds us that even in darkness, existence continues, steady, enduring, and profoundly calm. The ocean through human history. For as long as humans have lived near its shores, the ocean has shaped history. It has provided food, guided migration, inspired exploration, and connected distant civilizations. Though vast and often unpredictable, the sea has remained a constant presence in the story of humanity. Early coastal communities relied on the ocean for sustenance. Fish, shellfish, and seaweed became essential food sources. Archaeological evidence shows that some of the earliest known settlements developed along coastlines and river estuaries, where access to marine resources offered stability and nourishment. Over time, humans learned not only to gather from the sea, but to travel across it. Simple rafts and dugout canoes evolved into sailing vessels capable of crossing open waters. The development of navigation techniques, guided by stars, currents, and wind patterns, allowed ancient mariners to move between islands and continents. The Polynesians, for example, navigated vast stretches of the Pacific Ocean using celestial navigation, wave patterns, and knowledge of bird movements. Their voyages across thousands of kilometers stand as remarkable achievements of maritime understanding and environmental awareness. In the Mediterranean, seafaring civilizations such as the Phoenicians established extensive trade networks. Goods, ideas, languages, and technologies spread along shipping routes that connected Europe, Africa, and Asia. The ocean served not only as a pathway for commerce, but also as a bridge between cultures. During the Age of Exploration, European voyages expanded global maps and reshaped international exchange. Ships crossed the Atlantic and Pacific Oceans, linking continents in new ways. These journeys led to cultural contact, scientific discovery, and, at times, profound conflict. The ocean became both connector and frontier. Beyond trade and exploration, the sea has influenced mythology, art, and literature. Many cultures personified the ocean as a deity or powerful spirit. Stories of sea gods, mermaids, and legendary voyages reflect humanity's awe of its vastness. Even today, artists and writers draw inspiration from its shifting moods. Naval history also reflects the ocean's strategic importance. Control of sea routes has long shaped political power. Fleets protected trade, defended territories, and projected influence across regions. Yet, alongside military history, the sea has supported peaceful exchange and cooperation between nations. Scientific exploration of the ocean began in earnest during the 19th century. Expeditions, such as the voyage of HMS Challenger, laid foundations for modern oceanography. Researchers measured depths, collected marine specimens, and began to understand currents and chemistry. Since then, technological advances have allowed deeper and more precise study. In the modern era, the ocean continues to influence global economies. Shipping lanes transport goods between continents, supporting international trade. Fisheries provide livelihoods for millions of people. Coastal tourism connects communities to the calming presence of the sea. Yet, throughout history, the ocean has also remained a place of reflection. Its horizon suggests possibility. Its tides mark time with quiet reliability. For travelers, explorers, and coastal dwellers alike, the sea has offered both challenge and comfort. The story of humanity and the ocean is one of adaptation and connection. Across centuries, people have learned to read winds, follow currents, and respect the sea's rhythms. Though technology has changed, the fundamental relationship endures. A dialogue between land and water, between human curiosity and the vast blue expanse.